So let's go Control A and delete, and then let's get a lighting setup going here. Skylight, atmospheric light, all that stuff. And then let's just add a plane. And let's put it on 0, 0, 0. Scale it up a bit. Now I've added some images, 3 images here. One is a white dot, you can see here. One of them is going to represent the vision of our character. This just has an alpha gradient. So like this is transparent and then this is opaque. And then this one, a black square with a green box as the outline. What I'm going to do with these is organize them. So in a new folder, call it radar, put all of these images in there. And then another thing I'm going to do is add a player start there. And now we should be able to have that working. Next, I'm going to go in the radar folder. I'm going to add a user interface widget blueprint. And I'm also going to add, let's click this drop down here. I'm going to add an HUD. There we go. This is going to be called game HUD. This is going to be radar. And then in here, I'm just going to go to the event graph. And then when we start, we're going to create widget, add to viewport, and set the class to our radar that we added. And the owning player is going to be player owner. Compile, save that. And we're basically done with that. We just need to set it in here. There we go. Now to add the radar, I'm going to go in here and I'm going to add a canvas panel. It's not an input, it's in here. Add these 3 images. We don't need to anchor all of them to the center, but it just makes it easier. It sets the values. Now the green box is going to represent the entire map, basically, in our case. So I'm going to select the green box here, and I should probably rename these so that they're easier to identify. This is going to be radar border. This is radar vision, radar underscore player. There we go. And just reset them. Okay. Now for the size here, I'm going to set it to 280 by 280. This is just a value that I found worked pretty well. So this canvas panel just represents the entire screen. And we want the UI elements here to be shown on part of the screen. So this is a good size in our case. Now for the player is going to be pretty small, 10 by 10, maybe even smaller than that. And then radar vision is going to be 100 by 100. So because our images are squares, it's more ideal to have the size as a square. Now I'm going to move this to the top right, but Unreal is going to be a bit problematic here. If we move this, then what's going to happen is that these kind of get like misaligned. You can see that the position does not match exactly anymore. We can just set the position values for all these. What I found worked well was 650 and -280. Of course, you can pick a different area that's somewhere around here. 650, -280, 650, -280. Now this problem here where the white dot doesn't align with the vision, we'll get to that. First of all, I'm gonna set up the translation of the character, or movement of the character rather. So we're gonna set timer by event, and you could do this on tick, but we don't have to. And it's 0.05, and we're gonna loop it. Just a custom event, and this is gonna be called radar update. And we're just gonna set the translation of the radar player. Set render translation. We could do a set render transform. The only thing we need to worry about is the translation for this. If you remember, we set it up so that this UI is owned by the player controller. Let's right click, get player pawn, owning player pawn, and get actor location. And this is just going to convert. It's just going to take the X and Y values. This has a major problem right now. We just can't see the white dot. It's actually off the screen. If we get rid of this, we can see it in the center there. It goes off the screen because our UI is not actually the size of our plane here. To get the size of the plane, we're going to add a script, and all this is good. And we may as well add a new folder, put it in there. We can go to the event graph and then print string, get rid of that, get actor bounds, take the box extent here, and we actually want to multiply it. Multiply all elements by 2, just leave that there for about 20 seconds. We can see the size there is 1300 by 1300. We can increase that a little bit. Let's go 30 by 30 by 30. We can see the size there is 3000 by 3000. We know that the size of our radar is less than 280 by 280. To get a more precise size, we can add a border. And then just get that border, anchor it to the center here, and then just put it on 650, negative 280. And then 280 by 280. And then we can tint it black. This isn't actually visible in the game, or we can hide it in the game if we want. If we went with 260 by 260, that's obviously too small. If we went with 270 by 270, that's a little bit too big. If we go with 268 by 268, that lines up in our case. This is going to depend on the exact image that you're using. I need to put this above that. There we go. And this is the sort of thing that doesn't have to be like exactly precise, but as close as you can get it. So now we know the size of our radar is 268 by 268. We can take the 3000 that the edge length of this is and divide it by the 268 that the edge length of our radar is. That gives us about 11.194. And go back into here, in the graph here. If we just take our actor location, let's just divide this by 11.194. Use that. There we go. Let's actually just go ahead and hide this so that it doesn't get in our way. So now you can see as the player moves around, the white dot moves around, and it's accurate. If you're confused as to why this works, keep in mind that this is the 0, point of our world, and this is not actually the translation. The translation is 0, 0. The translation is only changing when we actually set it here. It's offsetting it from this position. We don't need to worry about handling that offset ourselves. Again, this is 0, 0. If this was not 0, 0, then we would have to do that offset. Now the vision is a bit more complicated. What we first have to do is add this in. We can set render transform. We can basically set the translation to the same value as the white dot. And the angle is actually going to be what controls the rotation. The problem is that if we just take this and then get control rotation, this yaw right here, this is going to create a problem for us. So if I play this, you can see that the vision is not actually aligned with the white dot there. In the designer here, we need to offset the vision because we want this to be in the center, right? So if we offset it by 40 units downward, then that turns out to be pretty good in this case. Again, it doesn't have to be perfect. This is actually going to create another problem for us. So you can see that the pivot point of the vision is not really on the white dot because it's in the center of the vision image. That's not what we want. If we go in here and adjust the pivot, we want to think about what value this is going to be. It says that it's a normalized value, which basically means that 0.5, 0.5 is at the center. So we offset this by 40 units, right? The size of this is 100 by 100. So 40 divided by 100, we get a 0.4 offset. Now 0.9 would actually move it downwards because this is 1, 1, this is 0, 0. We want to set this to 0.1. That will solve our problem. There we go. One other thing I'm going to do is add a box. And I'm going to add it to the center. Same thing as before, I'm going to add a script, add it to the objects folder, print the dimensions, all right, so our box is 700 by 700 on the X and Y. In our radar, we can add another radar border here. Let's anchor it to the center here. 650 minus 280. Let's take 700 divided by 11.194. And just copy paste that. There we go. Let's move that. This allows us to observe an issue. So you can see that the rotation of the camera does not really align with the rotation of the vision in the radar. If I'm looking this way, I'm definitely not looking towards the box, which is what the radar would indicate. This happens because the world rotation doesn't quite align with the way we've set this up. We could modify the image, or we could come in here and just subtract 90. So there you go, now it's accurate.